with a profound expertise in non-destructive testing, environmental construction, green materials and construction, the repair and rehabilitation of structure. Dr. Sharma has significantly contributed to advancing sustainable practices in civil engineering. His research endeavors have led to numerous publications and have earned him recognition in both national and international academic circles. Beyond his research, Dr. Sharma is dedicated to shaping the future of civil engineering through his commitment to education and mentorship. He has guided countless students and professionals, installing in them a passion for innovation and excellence. Without ado, please join me in welcoming Dr. Sanjay Sharma sir for his presentation. Thank you, everyone. Sir, session is yours.
So I am audible?
Yes, sir. Loud and clear.
So good afternoon, everyone, and once again I welcome you for this session. This particular session we will be discussing on green buildings. First of all, let me thank the organizer for giving this opportunity to interact with the participants. And I hope, let me share my presentation. So I understand that my presentation is visible.
Yes, sir. Your screen is visible, sir.
Okay. So I will go to this thing. So participants, this particular session we are going to discuss on green building construction practices, and maybe okay, whatever the thing we can consider about it's in automation type. So that also a little bit part is included in this presentation. But because I thought that let us focus on green building construction and sustainable construction practices, because where we are starting, and in any case, when we are going to say you have automation, so that is again leading towards your green construction, and ultimately our aim is going to be that we control our carbon footprints from this from adopting such practices. Uh, no doubt making the life easy, that is again going towards making our our world sustainable, and whole the focus now is on like reducing the carbon footprints, and that is what I say as per the Paris say agreement, we are committed to achieve of the carbon neutrality in near future also. So and there the green building are going to play an important role. So whatever basically now we are in construction practices we are going to include, so that should be the green construction practices or sustainable construction practices. So I think it is we all understand that, okay, to achieve the sustainable development, the contribution of the building sector is very very important. And if we go by this data, so our say CO2 emission from the building sector is about 22%, and we are consuming about 40% of the energy in the building sector. And that is why we are looking into our sustainable construction practices at the same time, through through our by adopting various measures including this automation in building sector, we are to achieve basically you can say that the word is now net zero building, but I think in nature we will be calling the decarbonized buildings. So so that is what we are looking into that. So that means that, okay, we want to have such buildings which are energy efficient and which are basically carbon positive buildings, or say net positive buildings. Uh, and seeing the say condition of our cities, like we are facing the problem of air pollution, etc. So there the role of this constructing a building which is net zero or the positive energy building is very very important. So, and I think this we all understand what is the impact of the global warming. We are already seeing the rising flood levels and flooding. We are seeing and change weather conditions. So whenever like you have this, even extreme winter is there or extreme summer is there, and whenever the rainfall is there, it is also like the rain is like happening basically in a shorter period. We are getting the lot of water. So that is not basically is leading to our saying say providing the say good city environment. And and floods are very common in the cities, wherever saying you are getting the fires and wildfires are there. I think the recent example of Los Angeles and many of these things is in front of us. So intense heat waves we are experiencing, and that is what is happening basically. Our that global temperature now, even the news was there, okay, what we are saying that okay we want to bring it down, but by 2 degrees centigrade, but it will rise. It is not may not be possible to control. And with the parents in USA opting out and all that, so it may not be possible to achieve this say target of lowering the says global temperature by 2 degrees centigrade. So so that is what thinking. So you can see that we are having the pollution, when a burning of crops is a major issue, particularly in the northern India and Punjab and all that. I are seeing we start hearing this particular thing from October end, and it continues up to this January end and all that. So and is all contributing to our say lifestyles where then burning of waste, burning of your crackers, and we already we are experiencing the huge acute water storage also shortage also. And the CO2 emission, so which was about very low in late 60s or so, but it has gone very high. I think there is a almost 45% increase in CO2 consideration within few years only. And India is the worst affected. I think most we have about 15 cities which are the worst cities with respect to the air pollution in the world. And Kanpur, Delhi are being, and this time I think Chandigarh, which is considered to be a very very green city or beautiful city, and green cover here is almost highest as per the as compared to any city in the country. But it was second most polluted city in the country after Delhi. So so this is what is happening, like uh, and it is not that we can control by having one particular measure. I think a lot of things are required to be done, which is which and you see that okay whenever there are some say control measures are there, so building or construction sector is the first one to be stopped basically during that particular period, because the this particular thing in our this thing. So that is what we want: cleaner water, cleaner air. And if you compare the Corona period, so what was the condition during that particular this thing? It was very very like understandable that most of the these activities are happening because of our say lifestyle. We are doing that. So so it is our duty to protect the environment around us, and in that section automation or say construction of green buildings is one of the things. And green buildings means that okay, I hope that everybody understands about what is a green building is. So green building is nothing. It is not like okay we plant the trees around that particular building or then we say it is a green building. Yeah, no. Green building means that okay we are taking a combination of measures like which may be like your suitable site selection, you are having the energy conservation, having the water efficiency, having the using the sustainable construction material, then controlling the indoor quality. So there are and most of the, if you are rating a particular building, so all those rating systems are based on this particular parameter, which these are five parameters, which like site selection, your water efficiency, energy efficiency, your material efficiency, and the indoor air quality. So there are four five rating systems which are there in the available in the country. This is the AGBC and Griha, Jam, and Leeds. So they are the one, basically they are based on these particular factors only, in and so so that is what that, okay, that with the because why we are going for green construction, or say this automation construction, is basically to have a safe sustainable earth in the near future. And it is important that, okay, we have the this sort of a situation where you get the good green cover. and and if you see, like now we are when we are talking about the decarbonized building, or say there also, uh, I think we have to calculate the balance between how much carbon dioxide is being emitted, and what are the measures which we are taking to which we are taking to to make this carbon dioxide balance zero, or so that means what are the sources from which carbon dioxide is being emitted, and what are the sink areas where the carbon dioxide will be absorbed. So there the trees will play an important role. And think there is a word forum which has basically categorized this particular into the three areas. In the first area, they have included certain activities in the building sector. In fact, in the second, they have included a few activities, and then third is the third parameter is basically where nothing is. Then where if some direct measures, some indirect measures, and in the third, other measures basically which are not in the control of that particular building owner and all that. So all these parameters will be from all these parameters you will be calculating how much is the carbon dioxide is being thrown, and then your this what are the carbon sinks around also. So a major part is being played by the green area in that particular this thing. So you calculate that how much one particular tree, what is the size of that tree. Based on that you will calculate what is the carbon sequestration capacity. So but this is very common site, heat islands. You have this thing. So your population is growing, so your technology is changing, your lifestyle is changing, because what we know is says it is a energy intensive lifestyle we are having. So we need for every activity we need some sort of energy. So, and cities, like, and you can see how big buildings, and their the construction practices have changed, and the materials they have changed. So so you can see different building forms are there, different multi-story buildings are there, and everywhere you are getting high rise buildings. So ठीक है, same way is Mumbai, same way is Kolkata, every bigger city. So but still, if we consider our, say, building sector, so what we have right now, we are still go a far away. For our needs, only 40% of built area has been provided. Otherwise, remaining is still to be built. So 60% existing is there, but by another say 10-15 years we need 40% more. So 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 that is what that, okay, because this building sector is basically contributing a lot towards this pollution and global warming, or say carbon dioxide emission. So basically we need to have such buildings which are say energy efficient buildings, which are say green buildings, and and then the responsibility is there for each and everybody. So policy makers, they will say that okay, uh, and when we say this is like engineers, architects, civil authorities, government, and some NGOs, developers, and all those things, all those persons are basically are responsible for carbon dioxide emission in building, and their responsibility is to control that carbon dioxide emission and go for the green construction. And and one of the parameters you say in the automation in this thing is also automation basically, because many of the things, if we are using this AI in building sector also, so that means that okay, there also we will be able to control, so we can be able to predict the things, and we will be able to adopt those practices which are the sustainable practices in the building construction. And energy wise also, you can say this because one of the factors is the energy efficiency. So every country in the world has its energy codes, and most of the you can find that okay, many places it is mandatory, but in many areas it is voluntary, and it is mixed. So but in India also now, I think it is mandatory in many of the places. If you have your electricity load or your construction area up to minimum of certain this thing, so they have already established, and you cannot construct. So every state has its own ECBC code, because energy efficiency code is basically is climate, it depends upon the climate. So basically for each climate zone, that every state has come up with its own ECBC code, and there the things are basically included is like okay, to achieve the near zero energy or zero energy buildings. Then so as you have a building which responds to the climate changes into the construction practices. You achieve the energy saving, but at the same time provide a good comfort to the occupants, expand coverage for the building types. So expanded coverage and mandatory implementation and enforcement. So this is what basically the ECBC code is giving us. So the components of any energy efficiency, say this will include is the building envelope, means is penetration or say orientation, etc. is going. Then comfort system and control. So there, I think it is important that what type of how you can provide the automation, or you use this AI application in the building, how you can control your say lighting into the building, and then what type of a system you can use to have a renewable energy sources in particular building. So so here also like if we are saying that this photovoltaics are being used, particularly if I can give the example of Chandigarh city. The Chandigarh city has already achieved its target of say 30% energy through solar energy. It was to be done by 2030, but already it is going beyond that. Now almost every house is being provided with this solar energy, and that they have used a net metering system here. Or okay, whatever the energy is being generated through the net metering, it is giving to going to the grid, and then through this net metering, it is basically that providing you the whatever energy you created, you are getting the payback for that particular purpose. Uh, so so this is important that okay, we do that. And this is the five climate zones in the particular in our this thing. And for each climate zone, so you have your ECBC code. Every state has its own ECBC code, basically, I will say. And and that is what you can see that the this scenario is changing. And you can see that in all the particular type of a climate, the different like ECBC and this building construction is going up. So, so it is going down. So so construction of a green buildings, or you have a sustainable building, if you define it, is the practice of increasing the efficiency with which buildings and their sites use energy, water, materials, and have the reduced impact on the human health and on the environment for the entire life cycle of a building. So so that means, okay, we want to have a building in such a way that, okay, which uses less water, which optimize the use of energy, which at the same time it conserves the natural resources and generates less waste and provides healthier spaces for the occupants. So we have to see that how we can use the natural resources like your sunlight, wind, or organic waste, and how we conserve the natural resources like your coal, water, and wood, etc., while carrying out the construction practices. So the benefits are direct benefits are there, and the social benefits are there, economic benefits are there. Mm. So environment benefits, okay, get the improved air quality, reduce water streams, conserve water sources. Social benefits are there, enhance occupant and health of the people. Okay. Economic benefits are there, you have the reduced operating cost. There are tax incentives, they create, expand and shape markets for the green production services and improve the occupant productivity. So many people says that, okay, I think maybe on that day somebody was not in your this thing, but in some other lecture. So the question was, why should we? Because green construction of a green building is a costly one. You definitely it initially you may be spending more. You are spending something on your say installing the solar panels, or maybe if you are having the multi-story building, if you are having that water automation is there, or so those things are adding the cost to the building construction. But the payback is about 3 to 5 years. So after that, you are, if you are economic wise, you are positive. So you are not spending anything on the energy. You are not spending, and then water is being recycled. So that water is again, so it is. If you go your building, national building code. So whenever you are going for any multi-story or any building of a particular size, you have to show that your net water balance is zero. No wastewater. You are not allowed to get a connection to the your sewage line. Whatever water you are generating, it is to be reused in your locality only. So those okay things are there. The same thing is happening in the energy also, so everywhere. So that means, so green building means that, okay, carbon emissions are reduced, your water use is reduced, your energy use is reduced, and when your solid waste is again not being it is recycled, it is not being thrown into your system, or all that also. So so you may have any maybe green home, green factories, and or your green data center, group housing complexes, green interiors, green metros, green cities, green campus, green township, and a green existing building, and green healthcare, etc. So it is not that, okay, one particular thing, but everything can be green around it also. And then that if you go for the life cycle of a particular building is, so here we are following the principle of reuse, recycle, and reduce. So whatever we are seeing, so that is what we want in our construction sector, we want in our environment sector also. All those things are to be included. So so that coming to the first like parameter of your green building construction is that, okay, we want to control the site related parameters, which may be environmental system sites, which must be avoided. Okay, sometimes you have an area near to some eco-sensitive zone, so there we have to take care of that also. Then we have to take proper precautions to prevent the erosion of the soil, then to preserve the top soil, to have it does not cause any air pollution, it does not cause any sort of a other this thing. So during construction, so we are to take the certain measures which are the site related parameters. And so, and then at the same time provide maximum open spaces, reduce impervious areas. And this is a like a good this thing, I think. Also one of the areas where I think intervention is required, because most of the time we cover our this thing areas with the paver blocks or roads or concrete like panel, etc. So there also you will get, okay, during summertime you will get a lot of heat is being generated. So why not to use those sort of materials which prevent the emission of the heat basically from that in the particular this thing. And basically, yes, the type of materials are available, like you are this tiles, which are used, okay, which are the pervious type of a tile from which the water ingress is allowed and all that also. And then then I think there are a lot of even government is winning money for this also, to to have a some sort of a like study how to reduce the heat island effects in the cities. And there I think now people are using this AI, like in GIS, through the GIS data is obtained, then okay, then you get the your this temperature or other like weather data from this thing, and then you design basically how the airflow is taking place, and accordingly you design your system so that whenever the whatever the heat island effects, they can be reduced to the minimum into this thing. So in that, with the every state has its own climate cell, and on the climate cell the emphasis is on basically this reducing the heat island effect in the city. And no doubt other things are there, like this thing, but yes, this is one of the major areas. So then that means to construct causing a minimum disturbance to the existing features and provide them a good trees, and again preserve the natural water bodies and provide the natural water bodies also in around this thing. Then your second parameter in the construction of green buildings is that water efficiency, which can be achieved by installing some intelligent features into the water management systems, like you have water sensor based your water taps, or you have your provide sort of irrigation also, where I think again they are the water sensitive or not also, because have the drip irrigation system, install those sensors basically, which can basically sense that, okay, that now the water, how much water is required to be provided in that particular your green area, and all that also. I recently happened to visit this Dubai, and there I have seen that, okay, it is a desert area, but if you go around your roads and all there, so you will find it is a lot of greenery there, a lot of flowers were there. And they have basically, what they have done is they have provided this like this drip irrigation system, or you in that particular along the roads also, and the water automatically basically whenever the water is required, automatically it is opened, so nobody is there to provide irrigate that lawn and water also. So that sort of a things are required to be done in our systems. So how to reduce water usage during construction, and during use of the when building is being occupied. So our thing is to adopt the technologies which reduce the water demand, which allows the water to be reused, at the same time which allows the water to be recharged. And now I think in our part and this northern part, the installation of a recharge well is very very common. But here what I have seen is, we how much water is being recharged or this, so nobody is having any sort of a information about that, whether that particular recharge system once constructed is working afterwards or not. And many times we are carrying out some activities related to the building completion certificate, where we see that, okay, how much whether the a builder has met the required commitments with respect to environment, with respect to water usage, with respect to energy usage, or with respect to this at the site. uh, so and also quality is also included, but these are the environmental parameters. Parameters are the one of the major things which we are looking into, and providing making a study or making a report based on the commitments made, or with respect to clearance given to that particular builder, and then that builder is issued by the authority the certificate. So there we are also trying to see that, okay, what is the basically they have done for this water efficiency, energy efficiency, other things. And at the same time, many areas they have provided this automation. Basically, we have installed the sensors like in the common area. So once you enter, your all the your electrical bulbs, etc., they start working, and as you go out, they, so that sort of things they are, people are trying to include these things in the building construction sector also. So water efficiency is required. So that is what you use the use the low flow fixtures, and use aerators and all that also into your system. Use the harvesting system, and provide the most efficient sewage treatment plants. Then use that treated water for your flushing, etc. I think nowadays, again, that as per code, you will not be given the clearance until unless you have the dual plumbing system installed into your building. Then water efficient landscaping is one, that is what I have just told you, that okay, you have this water. So then use the drought tolerant spices, so, and efficient management irrigation system. So that is what I said, that okay, you are through this thing, so use the like fixtures which help you in conservation of water. Plant the like plants which require low water, particularly depending upon your climate zone. And have a dual plumbing system. Okay? And then provide this wastewater collection, and then reuse that water for your this thing. So whatever the you are seeing, so achieve the zero balance into your this thing. So water efficiency during construction also. I think you must nowadays you are allowed to use water for curing, which is the treated water only. So what is the avoid the ponding method, or again use the captured water for your this thing, and at the same time use like systems basically during construction also. We can use that also. So achieving the water efficiency, having control on the site selection, then reducing the water efficiency through your say different means. I think is and go for automation in water control system and audit also, so you can achieve that water efficiency in the building. Then energy efficiency, I think we all know that okay, it is important. So basically energy is like seen into either there are two systems, passive control and then installing your this non-conscious sources of energy at the site. So in the passive measures, you will have, may not be possible always, but yes, building orientation by studying the sun path is important. So how, then like in which side you require energy, you require sun to enter, and in which period you require you want to sun enter. So that particular thing is studied. Most of the architects may be knowing about this thing, but then so have, that is what building envelope, control that building envelope. So have the proper shading, and use the high performance glass into the building. Use the proper type of a walling system, and also have a good efficient roof also. Then installation of the energy efficient HVAC equipment in the building is important, and you use the renewable energy, and use the efficient artificial lighting design also. So that is also, that can come through your automation part only. So then materials also, I think, important, because we use the lesser of a natural resources and use more of the recycled thing into our construction. So it is important. So use the recycled content, use and locally available material, also use the rapidly renewable materials also, like you are this thing, bamboo, etc. Maybe wherever it is. And then waste management is again one of the issues which which we should be taking care of during it may be during construction. and it may be after construction also. So wherever the things are there, so we have to, I think it is important nowadays, have the different type of waste collection systems, and recyclable, biodegradable, non biodegradable, and all those things are to be taken care of this thing. Mhm. And then have the system, so that means the indoor air quality use, that is important here. So have the good cleaning water, clean drinking water, proper toilets. These are for this thing. So that is what that was where we're talking about green buildings. So we have the different green rating systems are there. These are the systems like your I already said the Griha, which is a 1 to 5 star, and a gem is also 1 gem to 5 gem, and IGBC is again certified silver, gold, platinum, and lead is also certified silver, gold, platinum. So in this you have the different points to be achieved. So it may be 100 point. The Griha is like a 100 point this thing. So there this site selection is given certain points like your 6 to 10 points in your water efficiency. You have about 15 points in energy efficiency. You have 25 points in the material efficiency. You have again another 20 points, and then remaining in the into the indoor air quality. So that so that so in that particular this thing like electrical automation may be 1 point, in water efficiency automation may be 1 point, in construction practice also. So what practices you are using, what like your materials, it is a materials as well as the construction practices also. Nowadays we have the 3D printed houses also. And one of the colonies now in the of a border audition has been constructed here. That is the first one in that maybe in Chandigarh. I think you have seen one a particular post office was constructed in Bangalore city, which was the first 3D printed post office. Here also, border organization in Chandigarh, they have constructed one colony, which is a 3D, which whose construction was carried out by adopting the 3D printing practices. And now people are working on this particular side also, 3D printing technology. It is again, you can say automation in construction, because you have a big 3D printed machine, this thing, and that you take it to the shadow. You are all that concrete mixture is made, so you don't require, so that your mix of the required consistency is basically used. You don't require any form work. You don't require any curing. So you and that particular uh, and 3D printed houses also doesn't require any sort of a outside finish also. So it has got a many advantages. Basically, it is a this thing. No doubt the cost of that. So in near future, maybe your construction practices will change definitely in a different way. So there also all those things your and 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 same way like automation in the building construction also, like you have the prefabricated systems, prefabricated elements basically you are available. So they are all fabricated or made into a controlled condition. If you say take the example of edited ACC blocks. So ACC blocks, no doubt they are they like uh, uh, they are like have a microprocessor based construction system. So there the you have, you give a, the person is sitting at a control and he is basically giving how much cement is mixed, how much fly is to be mixed, how much water is to be mixed, and all the process is automatically controlled into these things. So you get whatever the material you are making, maybe panels, maybe blocks, or maybe some other these things. So it is all controlled at the site, and through automation it is done all the this thing, and there is a no wastage. If you happen to visit any ACC say block factory, you see that okay, no zero wastage here, and all thing is again curing is done in a steam curing is done, and and there is no stacking of the material. So whatever the like your order is there, so you make your that particular thing as per the requirement of your building, and then it is sent to the site. So that is what basically that we are looking for this thing. And so this is the gem. So ASSOCHAM basically. So they are the like IGBC is born from CII. ASSOCHAM is basically they are giving this gem rating system. Griha is basically again they are also there, the star rating system is given, and this is the leadership and energy and environment design, which is kind of US based basically. So they are giving called the lead rating system. So there are the five rating systems which are for which you are looking giving the certification as per your this need. So so that is what I think advantages. We are saving energy, we are saving water, we are saving, you are getting extra FAR into your system, you are having the reduced operational cost. Okay. And then more occupant productivity, and for builder better marketing is there for the project, and you are using and promoting the renewable energy through this particular thing. So that is what you can achieving by using this particular thing. So so another, that is what I said, that now we are talking about net zero or the decarbonized buildings, you can say. So here we are moving from that is green to net zero and to net positive. So it is basically with respect to emissions basically means. So that is what, so so basically what we are looking by 2050 as per our commitment, we are saying that okay, our building sector must operate at net zero carbon this thing. So that is what you have to measure your, even the existing buildings, they have to, I think like in Chandigarh we are already doing that. For our building, institute building, we have done the how much carbon dioxide we are generating. And a few of my students, so they have worked on some the MTech thesis for their own buildings they have worked, because some guidelines, as I said, is given by Griha. So under that, three phases are there, the three systems are, three measurement is done under three different categories. Category one includes certain parameters which are direct parameters which are using the energy, then other like your, which include your solar energy, etc. And third, like your transportation, which are not under your control. So from there, all this you are measuring your carbon dioxide emission. So that is what we are looking for, government agency and all that also, you will so basically a net zero carbon building is a highly energy efficient with all the remaining energy from on-site and off-site noble sources. So that is what you measure and disclose your carbon footprints, you reduce your energy demand then according to your this thing. So and then generate balance from renewables, okay, whatever and then improve the verification and rigor. So go for that particular testing. So in that you have to adopt all the things, some construction practices, your some say energy savings measures, and then through automation, etc., you have to provide that all those things basically which go for you. So that is what the word green building council, so they have given all those things. So go for that and get the certification. It may be done. So so that is what net zero energy means. Okay, you have the your highly efficiency provide HAVS, lighting, appliances, construction, etc. is all including. So provide a balance with energy systems and the renewable energies this thing, and achieve net zero or say net positive. Mm. So, so basically that okay, we have to achieve a balance between your development and your energy uses, etc. So that is what we have to. So buildings that through renewable means produce as much energy as they consume. So that is what we call is the net zero energy building. So we are not depending upon your energy needs from the outside. Um, so achieve that balance. So you have to look into all those things, like your this what is your load, what is your lighting, what your HVAC, what are the renewable energy sources you are using, and achieve that particular thing. So even one of my PhD students, he worked on, he was the first one. There was a one building which maybe mentioned, maybe there in the subsequent this thing. So there was a one building which was being constructed in Ludhiana. That building has been constructed as net zero energy building. So we developed the parameters which included all those things, non energy automation part, your this thing, your say energy through your thermal energy, not photovoltaics and solar energy, but even thermal. There's also control, how to control the HVACS system, etc. So all those things were these things. So he developed a sort of equation. Okay, how to design a, what are the parameters which are to be considered in design of a net zero energy building. So it is describe the concept of the building generating their own energy needs by noble on-site power generation. So it is maybe to achieving through photovoltaic panels, and so go for that is what I say, that okay, we strive to achieve this net positive energy system of a building. So basically you may get a lot of this thing. So all the landlords, developers, tenants, suppliers, etc., they have to play their role. And so net positive sustainability strategy lies in accurately defining each property's electricity use, carbon use, water use, and setting short-term and long-term goals for reducing the negative impact and promoting the positive impact. So look into that. It may not be one mayor, it may be combination of the many mayors. So achieve that, okay, you have to go for consider the this climate zone, and then you have to consider how much heat is being generated, in which direction heat is being generated, or what is the type of the cooling system you require in the summer. So all those things, what is the pairs area, how much the green cover to be provided, in which direction, what is the direction of the wind, and how basically natural ventilation can be enhanced. So all those things are to be included into your building construction system, and that is what you go for the proper orientation. Okay. So select the proper type of a material. It may be brick wall or cavity wall, AAC block, and a brick wall with insulation, and or RCC wall, whatever the basically you think it is a suitable in that particular area. So consider the U value of that particular this thing. So for that you may have to think of this thing window even. uh, है ना. So है ना, your glass system HBS है ना, high performance glass to be installed. Recently one building here was awarded this thing, that was a small house, 10 marla house, 250 square yard house, that was awarded basically because he showed it and he was given the certificate of zero energy building basically there also. So he also adopted all those measures there. So that is what you have to see, that okay, single glazing or double glazing is to be adopted depending upon your this thing. Okay, how much light you require to be transmitted into this thing, so your transmittance is important through windows, so so daylighting is to be improved. Then then if inside comfortable, what type of a material you are using for your construction. So inside temperature almost remain between 25 to 30 degrees in the comfort zone. Your natural ventilation, so air direction, and which type of a trees are to be provided, what will be their heights, how much, so that they, so all those things are basically need to be included into the this thing. Then what is the limit of the heat gain, what is the limit of the heat loss, because that again depend on the climate zone. You want that, okay, you are during winter, if it is a inside is hot, so it should not be allowed to lose the heat. At the same time in summer the gain inside, the temperature should not increase. So that sort of a things are to be installed into your this thing. So solar panels we already saw. So, building type, building blocks using bricks, using ACC blocks, you are using some insulation material, etc. So all those things are to be. Then cool roof is again one of the things which can considered nowadays. You are providing this thing. Fenestration is important. So that means where to provide the windows for, so that light can enter but heat does not enter. What type of a material is to be used. So all those things are, so double glazing system. Okay. Then mutual shading, that is a design also, na? Penetration you can say, architectural design. So recommend what are the like so you provide that how to control the lighting system. So provide automatic lighting controls, internal and say external lighting controls. You provide as occupancy sensors. You provide the daylight and motion sensor. You provide the astronomical time switch and photo sensors. Maintain minimum like your lighting power density. And you have a separate controls for the separate lighting. Also, you use the recommended LED features. Nowadays you are getting bulbs also which basically can store some your solar energy also, so you use that sort of appliances into your building. All that also the different side of this thing. And then also HVAC system, so variable refrigerant volvent, and so they should be provided. Chiller and other centrally air conditioned systems should also be of a proper rating. And a direct cooling system or radiant cooling system, geothermal cooling. So all those things basically, when I said that okay, we designed a building, so we considered basically in a particular this thing all those systems. It may be zero in one particular building, it may be may be absent in one particular system. So that we have to see that. So energy balance has to be provided. So once you develop a sort of a this thing, so there you develop that, so to provide the air channels and all also. So think of the things basically which can be provided, and by having this automation also, because automation is important here in the energy efficiency and water efficiency is very very important there also. So energy saving tips, etc. Then ECBC compliant and all up also. So basically also your external this thing, heat islands to be controlled. Okay. Then renewable energy integration. Even this particular example is there in not like building system, but yes, in the canal system also, like Gujarat it was done, but in Punjab also it has been done basically. Here this thing. So this is the what few of the buildings basically which are intelligent and say automated building in the country. You have the Paryavaran Bhavan of Environment and Forest Department, and then this is the Indira Paravaran Bhavan, which is again almost intelligent and automated building, which is again provided the five-star rating system, and it has got all the. So this is the first such net zero building in India, constructed by CPWD and occupied by Ministry of Environment, Forest and Climate Change. This is almost net zero energy building. Indian Habitat Center in Delhi also. It is also a five-star Giriha rated system. Not net zero, but yes, having the five-star rating system. This is the one particular building in Ludhiana, Bisa. So it is also ECBC compliant building, and where the it is a five-star rated building in your this thing, and meets all the parameters of a intelligent and the say automatic building in the this thing. This is the one building in Newark, which is Richardson Institute of Technology. This is the Seattle, Washington also. This is also one of the buildings, this thing. And this is also a house by one of the this thing which is called, which is the example of a climate responsive architecture. Okay. So many different types of a building. So this particular building is located again in USA, which is again a net zero energy building, having a large area. Uh, so basically, yet okay, you have to when we are go for this thing, so you can go for this design of a net zero building, which incorporates the best in the energy efficiency, environment performance, and advanced control using a whole building integrated design process. Or so basically, so go for particular this design, and which will include your all AI applications also into your this thing. So that is what uh, why we should go for the performance based design building, because it encourages innovation, it reduces owner risk, faster construction, better cost control, make optimal use of team members, and establish the measurable successful area. So basically yes, so go for this, uh, focus on energy efficiency, then focus on adding renewable energy, and then focus on having that particular automation into your this thing, and provide a sort of a model for your this thing. Architecture feature also included. So so that is what you have to the daylighting, thermal mass, natural ventilation, etc. Control on that also. So thermal mass means you are taking care of your like your material being used, which is having a good proper U value, depending upon the location in which you are located. So natural ventilation is again important, and so you have the you can go for automatic windows that can be controlled and operated, and depending upon your daytime. But like you have in you may have seen in planes, है ना? They have the window system. So depending upon you can have a control there. So if you है ना, you can allow the light to enter, or you may have a sort of a put that where you can provide sort of a basically it doesn't allow the light to enter, so it becomes dark and light, है ना, by your this system only. So this is what you have to install the intelligent systems here also. And so go for this installation, net is energy. This is another campus. So so small things can so more efficient solar panels, they are also based like they are based on their movement of the sun also. So they also and you have a automation control, so they rotate in the direction of the sun. You have the less window area while still fully managing the daylight in the this thing. Then a larger transparent collector creating more free warmed air. Then better thermal breaks in the window frames, leveraging the latest in the commercial windows and aluminum frame, driving down energy consumption, increasing comfort. The displacement ventilation in conference rooms and improving thermal comfort. Natural passive control in the stair walls. This thing, the daylighting controls during in your wherever you are required. So you go for that, and this is a again the energy modeling, and I go for energy modeling in your this thing. So have a use the tools to provide the energy modeling. There you see equest is the one you can download from, it is a freely available. So there if you provide the all the data, you are whatever the material construction, whatever the solar energy you are using, and all those you provide all data, so it will give you the energy balance in particular that particular this thing. So you can use particularly that sort of a thing. So see that, okay, how much space required heating, how much space required cooling, what type of pumps you are using, what type of ventilation fans and you are heating, water heating system, your lighting, and your equipment, etc., your fans, etc. All those things basically can be modeled, and your energy and those things can be properly controlled. Basically, energy users can be properly controlled. So basically you can see that, okay, this is one particular thing taken from this thing. So it shows that there is a 81% reduction in power requirements by having a these sort of a system installed into the building. So this is again one example of one, say in Kiratpur Sahib, they have constructed a Jange Azadi Museum. So there also they have adopted all those intelligent systems into our building this thing. So that is a is it's a having a building envelope which consists of a cavity walls and with proper insulation. Building envelope roof also it has the heat reflective tiles and a false ceiling is provided. Building and a glass system and a UPVC system has been provided. Proper air conditioning system, which is VRV system, has been provided. Electrical systems again, LED lighting, sensor, transformers, cabling, etc. Acoustics has been done properly, and merging and motoring of the systems. Like a BM system, beam system has been used to have the complete control. This is one again particular building which is a 5-star rating building in Chandigarh. You can see its designer also. So it during daytime you don't have to keep your lights open, and also there is no refrigeration as the air conditioning system installed in this building. Inside temperature, even outside temperature, when it is 42-degree, it remains almost well in control. 25 to 30 degree it remains. So with the fan, basically you achieve a good cooling effect. And this particular building has been used in many of the films also for that particular purpose. This is the Herida building. like Haryana Energy Development Authority, that was a PEDA. This is again a Griha 5-star rated building. So it has also adopted all those things into your system, all those things. So we have to go for this proper energy approach. You have to follow this proper design, integrated design, then follow the proper practices, implement the ECBC in design and construction, and then you see that involve get the support of each stakeholders, and then integrate the sustainable design with the integration of renewable energy, so that you can achieve energy efficiency, you can achieve construct a green building, and you can make a building climate responsive building. So all those things, I think, in near future, whenever we are going to design our building, so we have to do that also. So futuristic, you may get good design of the building and all also many times, and this is what may look like our buildings in near future. So that, and it will require all our systems to be installed into our building construction practices, and later on during operation of the building also we require all those parts of automation and all that also. Different features, different type of buildings may be there in near future, but but again, we can have a good, like, it is not that old were not there. So we have in India, we have a good practice of our old buildings, like Hawa Mahal is the one which you can say the naturally air conditioned building also. This is also one Haveli in your Bikaner, Rajasthan. This is the Taj Mahal, and all those things, buildings are basically there. So you can learn from our this thing. So you have what green features have been provided. Some material has been used which doesn't heat up and all that also. So this is important that okay, we go for this thing. So that is what to in order to save our planets, we construct the green buildings, environmental responsive buildings, and in that, wherever required, automation is important in each of the building in order also. So that is what we take a pledge. Okay, that is, you set our ACs. I think nowadays 24 ACs in near future will not come, which will go say 18 degree or so, because you don't require that much of temperature and not also. So so that is also your automation. Then electrical vehicles again, they are being used to save the power. This is so so that is what you, for sustainable practices, include your energy conservation, your this low water conservation, and your the installation of your say energy systems and solar panels, your maybe charging stations are to be provided also. So that is what you can. So that is, so you have to improve the environment. That is the purpose of automation, and in building sector at least. So apply for carbon strategies, so use more public transportation, use clean fuel, use your reduce the occupational exposure, increase access to the safe water, change consumption patterns to lower the use of the your harmful chemicals, and have always use a healthy approach in the policies, and then also ban smoking and use the sun protective behavior, etc. So those things are to be provided. So so that is what we want. That why we want is a green building is okay. We want the construction to ultimately save the planet, and to achieve our, at least in near future, our goal of achieving the carbon neutrality. I think building sector, where it has to play a very important role in that particular direction. So this is was the regarding with your green building construction at, for your for a better future. So thank you very much, and now we can discuss your maybe your own experiences you have, what you want to share with the other participants, and if you want to add something to my presentation, or if you want that okay, something I have missed, or you want to get clarification, you are most welcome.
So thank you for the presentation. Dear participants, the session is open for Q&A as well as for the feedback. Sir will be open for the Q&A question. Kindly join. You'll be all unmuted now. If you cannot unmute yourself, kindly give in the chat box. Excuse me, sir. I have a request from the technical team. Could you please switch on the video or camera, sir? Sanjay Sharma, sir.
Okay, what my okay, my video is okay because my that was not working. So okay, yeah, yes,
Yes, sir. We can see you, sir. Thank you.
okay. So so I have basically discussed with the with respect to your adopting those construction practices which will help in reducing our carbon footprints.
Second, I request participants. The sir is open for Q&A session. If you have anything to add or anything to ask or discuss, sir is open for Q&A session. Kindly join the session.
Okay, it was just an I think presentation which was not having anything, but yes, oriented towards like constructing a towards sustainable construction practices, and at the same time achieving your say building from building sector reducing your carbon footprints. So I think if there are no questions, then we can like stop this particular presentation and go to the next one.
Yes.
Yeah.
Yes, sir. Thank you. Thank you, sir. Thank you, Sanjay Sharma, sir, for joining us. On behalf of Patients of Technology and Sciences and Civil Engineering Department, we are very thankful to you for that enlightening presentation. And thank you for providing the insights of green building as well as the future of green buildings and what are the practices we have to do and what are the practices we have to stop to be a sustainable person and each person to be responsible for the green buildings as well as for the earth. Thank you, sir. Thank you so much for such a great presentation.
Thank you. Thank you. Okay.
Dear participants, you have feedback link in the chat box. Kindly fill the feedback link.